Bismillahirrahmanirrahim. This video is about limits of trigonometric functions. This is theorem in calculating the limit of trigonometric function. If we want to find limit for sine x as x approaches to a, we will get sine a, which means we substitute x equal to a. It's same for all basic trigonometrics, such as limit cos x as approach to a, so we will substitute the value of a. For example, if we want to find limit for the function sine 3 over x as x approaches to infinity, so we will substitute our limit value is infinity, so we substitute x equal to infinity. So we have sine 3 over infinity. So 3 over infinity is equal to 0. So we get sine 0, and sine 0 is equal to 0. Look at this example. Find limit for the function cos 1 over x minus 1 as x approaches to 1. So to solve this one, we will substitute x equal to 1. So now we have cos 1 over, substitute x equal to 1, so 1 minus 1. So we have cos 1 over 0. 1 over 0 is equal to infinity. So we have cos infinity, that is equal to infinity. Now look at this example. Find limit for the function cos 1 over x plus 1 as x approaches to infinity. So we will find cos 1 over, we substitute x equal to infinity. Infinity plus 1. So this one we get cos 1 over infinity. 1 over infinity is equal to 0. So we get cos 0. Cos 0 is equal to 1. Alright, look at this example. We want to find limit for the function cos x minus 1 over x squared minus 1 as x approaches to infinity. So as our x value is equal to 1, so we will substitute x equal to 1. So now we have cos 1 minus 1 over 1 square is 1 minus 1. So here we have cos 0 over 0. So 0 over 0 is the indeterminate form. So for this question, we can factorize the quadratic equation to solve the limit. So for this limit, our function cos x minus 1, and then we factorize x squared minus 1. We will get x plus 1, x minus 1. Then we can simplify. We can cancel x minus 1 and x minus 1. So the rest we get cos 1 over x plus 1. After simplify, then we can substitute x equal to 1. So we have cos 1 over, substitute x equal to 1, 1 plus 1. So here we get the answer is cos 1 over 2 is equal to 0.8776. This is squeezing theorem. For this subject, student needs to know these two theorems. First is, if we find limit for the function sin x over x as x approaches to 0, so this kind of limit will be equal to 1. Also, if we have limit for the function 1 minus cos x over x as x approaches to 0, this kind of limit will be equal to 0. Please remember these theorems. These theorems are used in solving the calculation of limit involving trigonometric function. For example, we want to find limit for the function sin 3x over x as x approaches to 0. So first, we will substitute x equal to 0 here. So we have sin 0 over 0. That is equal to 0 over 0. So 0 over 0 is indeterminate form. So to solve limit involve trigonometric and we have indeterminate form, so we need to adjust our function by using squeezing theorem. So look our question here. We have function sin, so we will use squeezing theorem for sin x. And to use squeezing theorem, we need to know that function here must be same with the function in the denominator. So for our question here, we have sin 3x. We need to adjust our function so that our 3x must be same with function in the denominator here. So to make our function in the denominator same with the function in the trigonometric function, so we need to multiply x with 3. In our denominator, multiply by 3. But we need to multiply in the numerator with the same value. So in the numerator also multiply by 3. Then we can write 3 at outside, multiply by limit x approaches to 0. So function in the limit is sin 3x over 3x. So this function, limit x approaches to 0, 3x over x, is like this squeezing theorem, limit x approaches to 0, sin x over x. This one will be equal to 0. So our answer is equal to 3 multiplied by 1. So we get the answer is equal to 3. Next example, we want to find limit sin y over y square as y approaches to 0. So first, we will substitute y equal to 0. So we get sin 0 over 0 square is 0. So we have 0 over 0 is the indeterminate form. So we will adjust our question as squeezing theorems, limit sin x over x. So for this question, we can write limit y approach to 0. So we can adjust as sin y over y square. We can separate as y multiplied by y. And then by using properties of limit, we can write limit y approach to 0. We separate this function 1 over y and then multiply by limit for the function y approaches to 0 for function sin y over y. We can separate this function by using properties of limit. And then for this one, we can substitute y equal to 0. So we have 1 over 0. For limit y approach to 0, sin y over y is like the squeezing theorem. This one is equal to 1. So calculate this one, 1 over 0 is equal to infinity actually. So infinity multiplied by 1, we get infinity. Infinity for our limit. Next example, we want to find limit tangent to x over x as x approaches to 0. So first, we will substitute x equal to 0. So we have tangent 0 over 0. That is, we get 0 over 0. 0 over 0 is indeterminate form. So we will adjust our function such as squeezing theorem. So now we can adjust tangent to x, that is equal to sine 2x over cos 2x over x. Then we can simplify our function such as sine 2x over x multiplied by cos 2x. Then we can separate this limit as limit x approaches to 0 for function 1 over we separate sine at first. We separate function sine 2x over x because we want to adjust like squeezing theorem, sine x over x, and then multiply by another limit x approach to 0. The rest is function 1 over cos 2x. Then we need to adjust function sine as squeezing theorem, so we need to make this function same with the function in denominator, so we need to multiply by 2. So we will multiply by 2 in the denominator and also for numerator. So this one we can write 2 multiply by limit x approaches to 0 sine 2x over 2x. Limit sine 2x over 2x, x approaches to 0 will be equal to 1 by using squeezing theorem. Multiply by, for limit x approaches to 0 cos 2x, we will substitute x equal to 0. So 1 over cos 0. So we get our answer is equal to 2 multiplied by cos 0 is equal to 1. So 2 multiplied by 1 and we get our answer is equal to 2.